Okay, yeah. So one of the things we realized as we're putting together the presentation here is, hey, great. We talked about what code engine is at high level. We showed all these cool demos and stuff, but we forgot to actually say, hey, what are all the cool features? And we didn't want to show this too early because it may not have meant anything without seeing code engine in action. But hopefully now that everybody on the call has seen code engine in action, you can actually start thinking, okay, what about this feature? What about that feature and stuff like that? And so that's why we sort of moved this sort of towards the end of the demo. And you can see, as we talked about, Code Engine is meant to run basically any containerized workload, whether it's web apps, functions, anything that responds to HTTP requests, anything that can containerized, batch jobs. We will be able to run those for you in isolation. Okay. We already talked about what you can do with applications in terms of seamlessness, in terms of versioning, all the other good stuff. Event orchestration. We're going to be demoing this in a sec, but I do want to point out that you can connect up to event producers, and there are two different ways you can do it. Obviously, you can talk to the event producer yourself directly, right? You could say, hey, GitLab, GitHub, whatever, send events through the webhook mechanism directly to my application. Here's the URL, go for it. Obviously, that works because your application, because the application is an HTTP serving one, it will respond to it, and that's all well and good. However, there are certain event sources or event producers that we will help you connect up to. As of today, we'll help you connect up to IBM Cloud Object Storage and a ping or cron event source. So you can get events on a periodic basis, maybe every night at midnight kind of a thing, okay? And what that means is we will actually talk to the event producer for you to create the subscription. So for example, you just tell us which object storage bucket you want to watch, and we will handle the rest for you. We will then get the events, deliver them to your application. We'll check the authentication to make sure it's coming from cause, you're not being spammed, all that good stuff. Okay, that's what I mean by helping out for you. You could have done it manually, but we do it out for you. We do have more event producers coming online, things like GitHub and stuff like that. Kafka is a very popular one. Watch for that in the not too distant future, but that's not there yet. We already demonstrated build from source, from Docker files, or from build packs. We talked about container registries. I do want to point out that we do support private and public registries. I think I hinted at that before. So you want to do Docker Hub or IBM Container Registry or anything else, that's fine, we can talk to it. We already talked a lot about how you can still access the infrastructure, meaning you can talk to Kubernetes and Knative or whatever under the covers if you want to. Hopefully you don't need to, but you can if you need to. Service bindings, we'll demo this in a sec. This allows you to connect up to services. Okay, so for example, let's say you're using Cloud Object Storage from IBM. You could just tell us which instance of your object storage to connect up to, and we will inject as environment variables into your application or your batch job the credentials needed to talk to it, and the URLs or the endpoints that you should talk to actually interact with that instance. Okay, so we make your life easier here, so you don't have to go figure out the credentials and how to get them into your application. We will inject them automatically for you. And we were talking about billing in terms of free tiers, and you only pay for when your workloads are active. All right. Any questions on that, or anything, Uwe, you think I glossed over too quickly?
Maybe not glossed over, but maybe this is something we want to emphasize. Very early on in our presentation, there was a question from Paolo who said, hey, how does IBM Code Engine integrate with other IBM cloud services? How is data ingestion processes? How does that work with event-driven application development? And I think this is exactly what we're going to be showing here next in the next demo, right? How do we bind to services, and how do we consume events?
Exactly. Yep. The next demo is going to do both. It's going to use service bindings and it's going to use event orchestration, both with Cloud Object Storage. So with that, great. Let's go ahead and talk about this life cycle of a thumbnail generation app. Okay, so the theory or the storyline here is I'm a developer. I need to create a enterprise quality application that generates thumbnails, and that's all well and good. But like a lot of developers, I don't jump to the final solution. I want to do it slowly, iteratively, and I want to do a proof of concept first and then slowly add the other stuff, because maybe I don't feel comfortable yet hooking it up to object storage right out the bat. Maybe some of this stuff is new to me, so I want to take it slow. Okay, so what I'm going to do is start out with a proof of concept application. Then an application is just going to be a simple web app that will generate thumbnails based upon the user uploading a picture to that web app. and it's going to process the image, generate a thumbnail, and just return it back over the exact same HTTP request so the user could see the thumbnail. And that just proves that my thumbnail logic itself works. Then I can work on building out the infrastructure around my thumbnail logic. And how I'm going to do that? Well, I'm going to add persistent store, meaning as people upload images, I'm going to store them in someplace permanent, because I don't want it all in memory inside my web app. I'm going to store them in a cloud object storage. And I'm not going to just store the incoming image, I'm going to store the thumbnail. This way, my web app can now actually show what's in the object store, and it's going to show images and thumbnails regardless of how they got there, right? Because maybe there are other people running the web app at the same time. Maybe people are using other mechanisms to actually push these images to my object store. So I'm going to use my thumbnail generation tool not just for the simple UI, but I want this thumbnail thing to process any image that gets uploaded to my object store, regardless of where it came from, okay? But first, rather than being completely event-driven, which is the last step, I'm going to process all the images in the object storage through a batch job, just to make sure the processing works in terms of talking to the object storage itself, because I want to make sure that that logic works properly. And of course, because it's a batch job, it's going to be on demand. But finally, when it's all said and done, now I feel comfortable that my code for talking to cloud object storage works properly, the web app works properly in terms of displaying things on the UI, life is good. Then finally I'm going to change it to actually get events from the object store itself. So as people upload things to the object store, regardless of how they do that, my web app will detect it. I'm sorry, the backend will detect it, process the images to generate the thumbnails, and my web app will just periodically query the object store to see what's been changed. Okay, lots of things going on there, but this is a typical way someone may actually develop their code, slowly, incrementally adding more and more features. Okay, okay, let's go back to the demo. I'm sorry, let's go back over here. Let's go ahead and go to my thumbnail page. And what I'm going to do here now, because as you might imagine, there's a lot of typing here, I'm going to let the computer do the typing for me. This is live, so it's risky. The demo gods are not shining well upon me, but it is real, okay? Just having the computer do the typing for me so you don't see me do copy and paste. So what I'm going to do now is I'm going to create an application called Thumbnail. And to prove that it's working, let's go back over here to my applications. You can actually see Thumbnail is being created, okay? Now, notice what I did. I gave it a name of the application and put it into my container image. Inside of here, I have an HTTP server. I have a web page that's going to be displayed when I actually hit the URL. And I'm going to have my thumbnail logic that will process images as they're uploaded to the web app through a simple HTTP request. Okay, so let's give this a sec and let's see how things are going here. Hold on a minute. Okay, it's almost there. Let me go ahead and close the insurance app. We're not going to need a load generator. Give it a sec here. This image is a little bit bigger, so it took a little bit longer to download. Come on. All right, up, ready to go. So let's go ahead and take the URL here for the application. And go here, paste it. And you can see, let me make it a little bit bigger so you folks can actually see it. Okay, so thumbnail generator web app. Not the most exciting thing in the world, but let's go ahead and have some fun. I like this guy. I'm going to download, I'm going to say, okay, I like that image. I could also choose something from disk. Let's go ahead and upload it to the web app. And hopefully if everything works, it should respond back with a thumbnail over here. There we go. And you can see a thumbnail. I could take another image, do that, create another thumbnail. Come on. There we go. Okay. So it's very simple request response web app. Everything's in memory. That's all well and good. I proved that my thumbnail code itself actually works. Okay, cool. So let's go ahead and take the next step in the process. Now, as I said, the next step is going to be store these images and retrieve the images from a cloud object storage. Okay, so what I'm going to do now is go to the IBM Cloud command line, and I'm going to create an instance of cloud object storage. I'm going to call it thumbnail cause. I'm going to use the light plan, and in terms of which region is we're going to make it global. Okay, so this should only take a second, hopefully. And you can see it created a new instance of Cloud Object Storage for me. Okay, now we have an instance of object storage, well and good. I need to now create a bucket in which to store my images. And we're going to call this one bucket 3. Okay, come on, there we go. Okay, create a bucket, called bucket, and it's in US South. Great. Let me go ahead and clear the screen. Now what I'm going to do is, and this is what we talked about before in terms of service bindings. What we're going to do is we're going to tell Code Engine to bind to my application. Which application? Thumbnail. I'm going to bind the service instance called thumbnail cause. Okay, so what this is going to do, let me kick it off because it takes a second. What this is going to do is it's going to go to our Cloud Object Storage and say, hey, for the instance called thumbnail cause, go give me all of the credentials I need to talk to it, meaning the user ID, the password to talk to it, what URLs should I use to talk to you, and all that stuff. We're going to take all that information. We're going to store it under the covers in a secret. For those of you who understand Kubernetes, you know what a secret is, right? It's basically a name value pair map, but it's encrypted at rest. We're going to take that secret and we're going to bind it to our application such that the information that's in the secret is going to be available to my application as environment variables. Okay, so now my application, once it knows about these environment variables, it's going to look for them and it's going to use that information to actually talk to cause to start processing images. Okay, so give it a second here for the load balancer to finish being ready. Because actually what it's actually doing is it's actually deploying this, another version of my application. Now it's not changing the source code. Rather, what it's doing is, because we modified our application from a Code Engine perspective to actually inject environment variables, to Code Engine, that's another version. Even though the code itself didn't change, the container image name didn't change, once Code Engine detected it's another version, it needed to do an upgrade to your application, and so under the covers, yes, it's actually uploading and deploying another version of the application, and as a user, I should have 0 downtime. But there's no code change, so if I actually hit refresh here, it shouldn't do anything new, no options yet, okay? Obviously, it lost the images because nothing's stored in persistent store yet, okay? So the application's up and running, but the application itself doesn't know about these environment variables because we didn't change our code yet. So in the background, I updated my application and I created a version 2 of the image that actually understands how to look for those environment variables. Okay, so it's going to look for, let me kick this off. It's going to look for the credentials that were injected by the service instance binding operation. It's also going to look for an environment variable called bucket. So it knows which bucket to look for in that Cloud Object Storage instance. Because for all I know, this application at some point in the future may actually look across multiple buckets, right? So for right now, we're going to just have it look at one particular bucket. And this is called thumb bucket 3 that we created in a previous step. All right, so let's give it a second here for the load balancer to finish. And just for fun, let's go ahead and hit refresh to see what it's saying. Hey, you can see it's actually ready. There we go. Okay, everything's ready at the same time. Okay, so exact same URL, application's now ready to go. Let's go ahead and test it out and see what happens. So let's go ahead and upload an image. Say upload. Now, what should happen if everything works is it's going to be uploading it to Cloud Object Storage. The web app itself will not update the images over here automatically. What it's going to do instead is, when it's done uploading, or I should say every second or so, it will actually pull the application running behind the scenes to see what's going on in the Cloud Object Storage. So this image right here didn't show up because I hit the upload button. I'm sorry, it did, but the web app didn't pull it down as a result of the image upload. It pulled it down because it's periodically querying Cloud Object Storage to see what's up there. And you can see what's up there right now is just the image, not its corresponding thumbnail. That's what this little job runner thing is going to do. However, we actually haven't created the batch job to do that processing yet. So let's go ahead and do that, okay? Let's create our batch job. Remember, all you need is a batch job name pointing to an image. Now, this job will need to know what bucket to talk to, the same way the application did. So that's why we gave it the environment variable. Now, just like the application, we need to bind the job to our cause instance. Okay, so it's the exact same thing you saw up here with the app bind, except it's a job bind. But it's basically doing the exact same thing. It's going out to Cloud Object Storage, making sure that's the exact same credentials we want to use. And if so, it's going to inject that secret into our job. Now keep in mind, because we're not running the job yet, all it's really doing is updating the definition of our batch job. Okay? And this will take a sec because my networking's a little slow here, so give it a minute. Let me think about this for a sec. Is there anything else to talk about? Okay, so the batch job is done. Yep, go ahead.
Oh, sorry, I was just pointing out that, you know, if anyone wants to try this themselves, just to fill the time while this is deploying here, that this is all out on GitHub, and I just pasted the link for this sort of step-by-step instruction, the tutorial out in GitHub into our chat, so everyone can just try this themselves.
Yep, exactly. And this is one of those tutorials I talked about where we go into agonizingly detailed explanation in terms of what's going on. So it's a great exercise for people that are new, not just to Code Engine, but to containers in general. We try to explain every little detail. Okay, so the batch job is there. So let's go ahead and hit run batch job, or thumbnail job runner. Give it a sec, because under the covers, excuse me, I got a terrible frog in my throat. It's going to download the image and run the actual batch job, and you can actually see it ran and it generated the thumbnail. And the reason it showed up here again is because the web app is periodically checking the Cloud Object Storage to see if something new's up there. So let's go ahead and upload a couple more images. I like that one. Oh, did I do it right? There we go. And let's do this one. The reason it's so slow, I can blame this on my home network sharing the screen. So you can see images, thumbnails are not there yet because I need to run the batch job again. Remember, this is on demand, right? So if I hit run again, hopefully these two thumbnails should show up in a second here. Give it a sec. Come on. It's toying with me. There we go, starting to show up. All right, so one batch job, looked for all images that don't have thumbnails, process it, web page detected it, tried checking with cause, life is good. All right, so that's all well and good. Now, what we're gonna do is, we are going to deploy a second application. Now this second application is going to listen for events from Cloud Object Storage, because it's all well and good we have this job runner thing, but I want to actually process events as they upload. So every single time I hit this upload image button, I want to see these thumbnails generate automatically. Now, because this demo and tutorial tries to show you as many different things as possible, what we're going to do is we're actually going to build this other image. I'm going to show you that happen through the command line. Now, as I mentioned before, the command line, unfortunately, is a little bit behind the UI in terms of hiding some of this complexity. So what I need to do first is generate a location of where to store these things in our image registry. And I'm going to store it in IBM Container Registry in a location called a namespace, a location which is a namespace called thumbnail ICR. So I just created that location like a folder in ICR to store it. Okay. Now I need to actually give the command line the credentials to talk to ICR, meaning I need to create a secret. We're going to say, okay, here's my API key. It's in a file on disk, and this is the container registry that it's actually for. Okay, so it's pointing to the exact same container registry that we used up here, us.icr.io. Okay, now what we're going to do is we're going to do a build. So what I'm going to do is first create the build definition. Let me go ahead and kick off the build since that takes a little bit of time while I talk to what these steps actually are. Okay, so I'm going to first create a build definition. I'm going to give it a name. I'm going to tell it where to store the image, right? So it's going to be in that location I just created up here. I'm going to tell where the source code is located. So it's in that same registry that we were just talking about on GitHub, IBM/Code Engine. I need to give it the secret, so the build process knows the credentials to talk to ICR to store it, and the directory in which to find my source code. So it's not just in the thumbnail directory in there, but inside there, there's a subdirectory called eventer. Okay, so as you can see, it's basically the exact same information as it would have had to give through the UI. Okay, now, we then kicked off a build. had to point to which build I'm going to kick off, and I pass in the wait option because I wanted to wait to see when it's actually finished. So under this behind the scenes, it did all the infrastructure to do a build. Now, notice I didn't specify a strategy, so this actually confirms what I thought. It will actually use Docker build to do it as by default if you don't specify a strategy. And the reason I know that is because I put a Docker file in there when I created the tutorial. Okay, so we now have a build. We have a new image built. And we have a new image called Inventor. So what we're going to do is we're going to deploy it. Now, a couple of things here while this is going. We are going to deploy an application called Inventor. We're going to use the image that we just built because it's pointing to the registry, ICR, in that namespace we created, image name. We need to give it the credentials to talk to ICR to download automatically for us, right? So we're going to use that exact same secret. But there's one extra little thing here. Notice this -- cluster local at the end, okay? What that's telling Code Engine to do is to, sure, deploy the application, but don't give it an external endpoint. This is a back-end service. We do not want it available on the internet so that any random Joe can hit it, right? We don't want people trying to tell our event processing logic to kick off just willy-nilly. We only want the Inventor to get events from things inside of the cluster, in particular, only from Cloud Object Storage, okay? And that's why if you look here, the URL that's spit out, it's not the same URL that you see up here with appdomain.cloud, right? The URL here is only available from inside the cluster, all right? And that is the exact same URL that we're going to use when we actually create our subscription to Cloud Object Storage. But one other thing we need to do first is we need to bind this application to our instance of Cloud Object Storage, because just like the web app serving thing, just like the batch job, those things need to have access to Cloud Object Storage, and only applications, or I'm sorry, only workloads that have the credentials will be able to talk to it, okay? So we've now bound our Inventor application to Cloud Object Storage, so it should be able to talk to it. We're almost ready to go. What's missing? Well, we need to create that subscription I talked about, right? Now, I could technically probably go to, like I said, the event producers, set up whatever webhooks, subscriptions, whatever is necessary to send events to my applications. But Code Engine makes it easy for us. What we're going to do is we're going to leverage, let me just stop the screen, the subscription object or resource. We're going to create a cause subscription, right? So cause create, give it a name of cause watch. We are going to tell it what bucket to watch, okay? Thumb bucket 3. And it will figure out which cause instance. So it's trying to do some magic under the covers for you. Now, we need to tell it where to send those events when they actually do occur. And in this particular case, we're going to send it to Inventor, which is that application we just deployed. Okay? Now, you can specify any application you want inside your project. You can also specify batch jobs. So if I did a subscription to the ping service, which is cron, if you remember, right? If I want to run a batch job every day at midnight kind of thing, I can change my destination to be the name of a batch job. The only thing you need to do is you need to specify another flag that says destination type, because you may have a batch job and application that just happen to have the same name. So we need you to specify the destination type if it is a batch job. But by default, we assume it's an application, because typically applications are the ones you want to respond to events, right? Just like functions and stuff like that. Okay, so we're going to create an application, a subscription to cause, right? And it did all the magic under the covers. It talked to cause for us. Life is good. Now what we need to do, though, is we need to update our application, because what I want to do is I want to hide this button. Now, I was smart. When I wrote this version of my application, I knew I was going to do that, but I didn't want to do it right off the bat. Okay, so instead, what I did is I made it hideable through an environment variable. And what I'm going to do is enable that environment variable, or set the environment variable to true to enable that logic to hide the button. Okay. However, everything else should technically be running. So let me go ahead and refresh the screen here, and you should just see, because it hasn't finished updating the application yet, you can still see the thumbnail job rudder button here, but you can still see I didn't lose any images because they're still stored in Cloud Object Storage, as they should be. So let's go ahead and test this thing out and see what happens. Let's take this image, drop it here. Now, if the demo gods are on my side, what should happen, it should upload it. You should see it on the left-hand side first, and then you should, after a second or two, see the thumbnail pop up if we get the event. And bam, you see it, okay? So we actually now have everything set up automatically. You see? Now, everything's all done there. It's updated. Let's go refresh the screen. You can see the button is now gone, right? Let's go ahead and do this just for fun. Let's upload the image many, many times. Let's see if I can stress my system. Unfortunately, I probably picked the wrong image. I know this one is a very high resolution. That's why it's a little slow. But you can see as they get uploaded, I'm getting events as I'm going along, and the backend system is processing them automatically. Okay? Not sure. Right. There we go. Took a little second there. All right. So that is a thumbnail generation service or application, right? Let's see if we do talk. I don't think we talk about it anymore. So, whoops. So that's the entire demo for this one. Okay. You can see runs through very simple proof of concept, integrates into services, shows you eventing, shows you build, all in one mammoth application.